So Jai Hind everyone. So today we will discuss about various concurrency control protocol like validation based protocol, multi-granularity and multi-version concurrency control. Okay. So first we will see what is validation based protocol. Generally we have seen that there are lots of transactions are there, but in maximum of the transactions, read operations is more as compared to write operation. So validation based protocol is generally applied on where read operations are more as compared to write operations. So basically it is applied in through three phases, that is first phase is read phase, another is validation phase, another is write phase. So in read phase where the transaction T is a read and execute, we have issued a read operation. So it is used to read the value of the various data items and store them in a temporary local variable, so that once the data item has been read, it will change by another transaction. So its previous value is already stored in local variable. So it can perform all the write operation on temporary variable without any update to the actual database, so that we cannot modify the actual database, just read the value of that particular variable which we want to modify. Okay. Next phase is validation phase. So in this phase basically we have to validate the temporary variable value. It should be validated, so that it should be checked with the actual operation, whether the actual operation change the value or not. If it change the value, then only it will redirect the changed value or the new value to the actual database, otherwise not. So just to avoid different types of there are log based recovery or there are many failures, so we have to avoid different types of failures. Okay. The last phase is write phase. If the validation of the transaction is validated, then only the temporary result will be will reflect into the database. Otherwise the transaction must be rollback. Okay. Validation based protocol, basically it has three phases. So start, time stamping, TS stands for time stamping. The TI is the time where TI started its execution. The next phase is validation, TS, TI, the time when the TI enters its validation phase. Once the operation has been applied to the particular value and the value can be changed, or it can be a read phase only then. The last is finish. So the time when TI finished its write phase. If the value has been changed in temporary variable, then it must be write into the database. So validation test use above time stamping and read or write set to ensure that serializability order is determined by validation time. Thus, TS, TI is equals to validation time stamping. Both time stamping must be same. Okay. Validation based protocol has been found to give greater degree of concurrency than locking time stamping operation if probability of conflicts is low. It provides high concurrency, greater concurrency degree. Okay. So this is the validation test. We have to identify the test, validation test. If, for example, let's say there are three phases are there. So for all TI, the time stamping of this read phase with time stamping is lesser than the time stamping of TJ. TJ should be greater. Either one of the following condition. Okay. The first condition is that the finish time stamping is lesser than the start time stamping, or second one is start time stamping is lesser than the finish time stamping. Okay. And finish time stamping is lesser than the validation time stamping. And the set of data item written by the TI does not intersect with the set of data items read by TJ. It means for what? If we start the first phase where finish time stamping is lesser than the start time stamping, this is first condition. Second condition is validation time stamping must be always greater than finish, and finish is greater than the start. So it means the start time stamping is first, then finish, and then validation. And the set of data item written by the TI does not intersect with the data item read by TJ. Then the validation succeed and Tj can be committed only in this case. Otherwise, the validation fails and Tj should be aborted. Okay. So the justification of this is, if we apply the first condition when the execution is not concurrent, then write of Tj do not affect the read value of Ti. And in another case, in the second condition holds, execution is concurrent, Tj does not hold read and write item written by Tj. That's why. This is the basically justification to that. This is the validation test. Either the validation test failed or not. Okay. So validation test is succeeded only if either number one, start time stamping is greater than the finish time stamping, or second one is validation time stamping is greater than the finish time stamping and finish time stamping greater than the start time stamping. And one more thing is that the set of data item written by the Ti does not intersect with the set of data item read by the Tj. Then only the validation test succeeded and Tj should be committed. Let's say the schedule produced by validation based. So this is the example. T5, read B operation, read B and do some operation in B and read A plus 50. So we have to identify in different transactions that we have to change the value of B and as well as A and then validate, display A plus B, validate B and A. We have to validate both B and B. So in this case, what will happen? It happens that if we change the value of B and value of A, it read the value of A, display A plus B. What it display A plus B? It display whether the changed transaction or the read B, the previous value of read B. Just because of it validates. Validation, it means it validates the whether the read value of A and B is correct or not. If it is correct, then it display A plus B. So what is the meaning of correct? Read A, it is this read operation after the transaction, this the value of changed and then read, but the value of B is read before its final update. Validation, it means it validated this particular transaction and changed the value of this B and displayed. It means the changed value of A plus changed value of B has been displayed. Then validate, write B and write A. Then it's validate and B and A is finally overwrite in the final transaction. So this is multiple granularity. What is multiple granularity? It is basically granularity. It means the size of the data item allowed to lock. What is the size of data item that should be locked? So multiple granularity can be defined as a hierarchical breaking up to the database into blocks which can be logged. The second one, the multiple granularity protocol enhance the concurrency and reduce lock overheads. The third one, maintain the track of what to lock and how to lock. The fourth one, make easy to decide either the lock a data item or to unlock a data item, and this type of hierarchy can be graphically represented as a tree. That's why this particular granularity can be better understood by a graphical structure. So let's say this is a graphical structure of the multiple granularity. Like for example, the first node is treated as a database, the complete database. Okay. Then the database is further divided into two parts. These are the areas, area 1 and area 2. Okay. The area can be A1, A2, A3 and AN. And this area can be further broken into various files, file A, file B, file C and so on, file N. And the file must have some records, and the records numbering is started as RA1, RA2, RAN from the file A, from file B, RB1, RB2 and RBK, from the file C, RC1, RC2, RC3 and RCM. So these are the various levels of a multiple granularity tree. So first is the database, second is the area, the third one is file and fourth one is record. Many times the question in examination that if we draw a hierarchical diagram in multiple granularity, what are these 4 steps? These 4 levels name. What are these 4 levels name? The levels names are database, area, file and records. Okay. So 3 lock condition. Now in multiple granularity, basically what is the new thing? we have studied that there are two types of lock, that is a shared lock and exclusive lock. In multiple granularity, three more additional types of lock, that is called intention shared IS, intention exclusive IX, shared and intention exclusive SIX. These three types of locks also has been studied into this multiple granularity. So what are these three additional locks? If we talk about the intention shared, it means indicate explicit locking at a lower level of the tree, but only with the shared lock. What does it mean? It indicate explicit locking at a lower level, but keep in mind that it is a shared lock, so it will be applied only when this is in shared lock. Intention exclusive. So what does it mean? It is also same as intention shared, indicate explicit locking at a lower level, but with exclusive or shared lock in any mode. Just because of, if we had applied with exclusive lock, then it is very obvious we can apply intention exclusive. If we have applied shared lock, then what? If we applied shared lock, so in growing phase, the shared lock can be converted into a exclusive lock. So we can apply intention exclusive lock with the shared lock also. Shared and intention exclusive. The subtree rooted by that node is locked explicitly in shared mode, and explicitly locking is being done at the lower level with exclusive mode only. It means for what? If we have only exclusive mode, then we have to apply shared and intention exclusive mode. Whether the operation is read or write, it doesn't matter, but we have to apply shared and intention exclusive. Okay. This is a compatibility matrix for all locks mode, that if this is intention shared, intention exclusive, shared, intention exclusive, and exclusive. These are the, so if we have applied intention shared lock, so we can apply intention shared lock. If we apply intention shared lock, then we can also apply intention exclusive, just because of intention shared lock can be converted into intention exclusive. Okay. Intention shared can be applied with a shared lock. SIX, shared intention exclusive, yes, but only exclusive. It cannot be done. It cannot be done if once the item is intention shared lock has been applied to one of the item, then it cannot be applied exclusive lock, just because of exclusive lock is the write operation. Intention shared, it means we have to read the value. So we can apply intention exclusive, shared, intention shared, shared intention exclusive, but not the exclusive. Okay. So in the similar fashion, if this is intention exclusive, then we can apply intention shared and intention exclusive, others are not. And if we have applied only shared locking, then we can apply intention shared locking, no other locks. If this is shared and intention exclusive, then we can apply intention shared, nothing. In shared lock, we can apply shared also. In exclusive, no other locks can be granted. Once the item is in exclusive mode, then no other lock will be granted to that particular variable after exclusive lock has been applied. Okay. So what is the purpose of these three locks to be here? Just intention, it means if there is a 4 levels, one is database, another is area, then file, then record. So if we apply only exclusive or shared lock, then this is very complicated matrix, and we cannot apply, once the item is shared lock, that we cannot apply exclusive lock. So just to modify the version, just because of there are different levels and we have to apply any lock at a lower level, then we have to justify that what will be the lock at its upper level. That's why different types of locks are available in this multiple granularity. So these are the various conditions for multiple granularity. Okay. So listen about carefully. Transaction T1 should follow the lock compatibility matrix. Obviously. Transaction T1 first lock the root and the tree of the tree. Root of the tree. The first lock the root. It can lock in any of the mode, okay. Transaction T1 currently has the parent of the node locked by either in intention exclusive or intention shared mode. Then the transaction T1 will be locked in shared and intention shared mode only. Intention exclusive and shared, intention exclusive and shared, intention shared. So in this case, and in this case. So what will be written? Shared and exclusive mode only. Shared and intention shared. Intention shared. This is. Okay. So this description is basically describe this particular table. So what type of locks can be provided with the if we have applied this type of lock, the other types of lock can be granted to the particular variable. Okay. So in multiple granularity, the lock are acquired in top-down approach, and lock must be released in bottom-up order. So if we apply any lock, so it should be applied. First, we apply the lock to its top level. It means we have to apply the lock in database, then area, then file, and then record. But if we release the lock, the first we have to release the lock from record, and then from file, then from area, and then from the database. Okay. So these are the different examples. So how to apply the lock and how to release the lock. So if transaction T1 read record in RA9, what does it mean RA9? This is the record RA9, this somehow here RA9. Okay. Then the transaction of T1 needs to log the area A1. So it means it should log this particular F and to this particular area. It should log this area A1 and file FA and this file FA. These two should be in logged mode in intention exclusive. Finally, it needs to be log RA2 in shared mode, just because TI needs to be read operation. So that's why this A2 in shared mode, sorry, not A2, A9 is in shared mode only. Okay. So for example, let's take another example. If to modify, this is the read operation and this is a modify, read A9. The same variable can be modified by another transaction. Then it can be do so after locking the database of area A1 and file A in intention exclusive. Finally, it needs to be RA9 in exclusive mode, just because of this operation tends to modify the particular variable. Okay. So these are the different operations. Like if T3 reads all the records in the file A, all the records, then the transaction T3 read the log needs to lock the database and area A in intention shared. At last, it needs to be file A in shared mode. It means we have to read the record of file A. We have to read all the record of file A. These all record in file A. We have to read all the record. Then the transaction T3 needs to lock the database and area. It means we have to lock this area and this database also. Okay. Just because of if we apply any type of lock in these records, then we have to apply lock in this mode and this mode. But we have not applied in lock in this mode. But we apply the lock in file, then we should apply the lock in area and database. Okay. So if this is in read mode, then file A should be in shared mode. And similarly, if it is in exclusive mode, it means it modify the record, then it should be in exclusive mode. Okay. So next one is T4 read the entire database, then T4 needs to be log the database in shared mode. Let's say T4 needs the entire database. It means we have to read all the area, all the files and all the records. Then what? Then the database should be in shared mode. This particular database should be in shared mode. Okay. So this is a multiple granularity. Like for example, if another transaction want to do something, suppose this is the read operation and this is the exclusive mode operation on different data item. So it should apply the exclusive lock here intention exclusive, but there is no lock on this. So we can apply the another area, another record, we can do the changes in another form. So this is basically the multiple granularity scheme. Okay, this is phantom phenomena. Let's see a very simple example. What is phantom? Phantom, it means false phenomena. Let's say, for example, if we have updated any record, but you read the previous value, but the record has been changed. So what we say, that you have read the fake value or the false value. So this is called phantom phenomena. Okay, let's take for example, if a transaction T1 that performs the predicate read, it read the value. For example, by this query, select count asterisk from the instructor where department is physics, whatever the value is. So, and then another transaction, insert a new variable. So what it read? It read the previous value, but we have already inserted a new value in this database. So what is this? This is called phantom phenomena. It means we read the false value. This is called phantom phenomena. Okay. Multiversion concurrency control. What is multiversion concurrency control? This is another type of, or we can say this is the advanced level of concurrency control. There are lots of protocol in concurrency control, like if we talk about serializability, view serializability, then different types of shared and exclusive lock, different types of locks, then validation based, graph based protocol, multiple granularity, and the last multiversion concurrency control, that is named as MVCC also. So basically, it do not block the writer. Listen carefully. If it provides the concurrency access to the database without locking the database, so that readers do not block writers and writers do not block readers. This is the main objective of this. So MVCC improves the performance of database application in multi-user environment. So basically, this type of concurrency control protocol is applied where if a database can be accessed by the different types of users, multi-users environment, then we can apply this multiversion concurrency control, so that in this way that the reader do not block writer and writer do not block reader. This is the basically phenomenon. Multiversion concurrency protocol provide each connected to the database with a consistent point time snapshot of the database. It means for what? There is a time stamping protocol, so we should use the time stamping in this multiversion concurrency control. So other user of the database do not see any changes until the transaction is committed. So once the transaction has been written, has been applied with the exclusive mode, then the other users of database do not see any changes until the transaction is finally committed. Like for example, if there are take an example of railway reservation. There are multiple users are there who want to book a seat. There is only one seat. Okay. So I am booking a seat. It shows that this seat is vacant. So I am applying to book my seat. I start the transaction. I start paying the transaction, but at last the transaction was not committed, the payment has been failure. So in this duration, the other users see that the seat has been already booked, because of I am taking the advantage of that particular free seat to be booked to me only. But when the transaction is failure, then according to time stamping, the next user automatically take the seat. So the effect of my booking do not affect the other transaction. It shows that this is under process, it will not booked by anyone. So multiversion schemes. Basically, there are two types of variants are there: multiversion time stamping and multiversion two-phase locking. Key ideas are: each successfully write result in the creation of the new version of the data item retain. We have to use time stamping. When a read queue operation is issued, select an appropriate version of the queue based on time stamping of the transaction. issuing the read request and the return the value of the selected. And read never have to wait. Read never have to wait. If we have to read anything, it should never have to wait. Whatever the transaction is in written phase or in exclusive mode, we have to read either the previous value or the later value. So, multi-version time stamping order. So, we will discuss these two different types of multi-version time stamping or multi-version two-phase locking. So, first we will discuss multi-version time stamping ordering. So, each data item Q has a sequence of versions, that is Q1, Q2 and Qn. Okay. Each version of Qk contains three fields. The one is the content, the value of the version Qk. What is the value? Second is the write time stamping. If we want to change the value of Q item, then time stamping. The read time stamping, when the particular variable has been read. Okay. So, the three value, the content, the write time stamping and the read time stamping. Now, suppose the transaction Ti. Now, we have to check whether the validation, or we can say that the rules. So, if Ti issue a read or write command, then what will happen? If Ti issue a read command, then listen carefully, read command. Already the database holds the value of Q, the read time stamping and write time stamping. So, the value returned is the content of the version. Just because of it already read the value of K, so it reflect the current value of Q has been reflected to the user. And if write time stamping is lesser than the time stamping, then the read time stamping is equals to the time stamping of Ti. For example, we have applied a read time stamping. Another transaction do another transaction read or write. If this is lower and we have read the value already, then the read time stamping should be equal to the time stamping of another transaction, just to avoid different types of various rollback. Okay. If Ti issue a write command, then the Ti is lesser than the write time stamping, then the transaction Ti is rollback. Just because of we have to write we have to change the value of Q. Then Ts time stamping of Ti is lesser than the read time stamping. Means read time stamping is later, the value of Q has been read later. So, it should be rollback. Just because of if read is later, then we have somehow changed the value of Q. That's why. If time stamping is equals to the write time stamping, then the content of QA are overwritten. If both time stamping, write time stamping and the time stamping of Ti is equals, then the content of Qk are overwritten. Otherwise, a new version of Qj is created. New version Qj, it means everything is new. The content of Q, the read time stamping and the write time stamping. Everything has been initialized in another transaction. Okay. So, these are the three conditions. So, read always succeed, every time read always succeed, but write is not always succeed. Write Ti is rejected if some other transaction Tj that is serialized order defined by time stamping value should read Ti write has already read a version created by the transaction older than Ti. So, the write transaction can be rejected when if another transaction has read the previous value, then the write transaction should be rejected. Okay. This protocol guaranteed the serializability. Okay. And what is serializability? A non-serial schedule that can be converted into a serial schedule called serializability. But the final answer should be same. This is a multi-version two-phase locking. So, it is basically differentiate between a read-only transaction and update transaction. So, update transaction acquire read and write locks, the both locks, and hold the locks up to the end of transaction, up to the commit of the transaction. That is, update transaction follow these two conditions. The one is read of a data item, return the latest version of the item, not the previous one. If the first write of Q by Ti result, then the new version of QI item Q is written. Latest version of Q. Read the latest version. If the value of Q has been changed, that it only read the new value. First write of Q by Ti result in the creation of the new version of Q. Okay. So write time stamping set to be initially as a infinite. Okay. When update transaction completes, commit, then value TS counter, time stamping counter. The TS counter can be better understood by in a way that the time stamping is never used from our clock. The time stamping can be used either a simple counter or it take the machine time. So TS counter stored in the database is used to assign the time stamping. Time stamping assign, and then TS counter is logged in two-phase manner. Then TSTI is equals to TS counter plus 1, just because of we have to do another transaction. So we have to increase the value of TS counter. Then write time stamping is equals to TS for all version that create, and the TS counter is equals to the 1 increment in existing TS counter. Okay. So multi-version two-phase locking में next है read only transaction. That is basically assigned a time stamping is equal to TS counter when they start execution, and follow the multi-version time stamping ordering protocol for a performing read and do not obtain any lock. Okay, and read only transaction that start Ti in increment, TS counter will see the value updated by Ti. Okay, or in this case the everything is done in the serializable order. So it maintain the serializable schedule. But there are various types of issues are there in implementing of MVCC. Just that if different types of different users are accessing a same database, then if we inserted the new records, then what will happen? If we delete some record, then what will happen? So basically, if we enter the new record, that create a problem. And if we delete some records, or if we overwrite the new version of Q has been implemented, then again and again Q read the value of Q and again store the latest value of Q and write time stamping, read time stamping, that it's a temporary memory can be full. So basically, and next issue is that various types of key constraints are there. So if we apply primary key and foreign key constraints, then it should check the first key constraint, then only it will change. So this is basically, these are the some implementation issues. So that's all for now. So thank you.